Hi guys, so today we are going to begin Unit 5, and Unit 5 is all about solving quadratics using different methods throughout the unit. So today we're going to take a look at solving quadratics with factoring. For your central question, I want you to explain what it means to solve a quadratic. Before we get to our vocabulary and our guided practice today, I do want to take a look at an explore problem, something we've seen before. So first I want to remind you that standard form of a quadratic equation is y equals ax squared plus bx plus c. So if we had the equation y equals x squared minus 2x minus 3, I want to go ahead and graph this equation. So remember, in order for us to graph, we have to find the vertex. And just a little verbal reminder, to find the vertex, we have to use x equals negative b over 2 times a, which gives us the axis of symmetry and is also the x value of the vertex. We will then plug that x value back into the equation for x to give us our value of y. So for this equation here, our vertex is going to be at 1, negative 4. So remember, also we want to take a look at our a value. Our a value for this equation is going to be a 1. And remember, it's that invisible number in front of the x squared if it's not written. So a equals 1, that's a positive 1. So our graph will open up. Our y-intercept will be at negative 3. I also want to look at factored form. So remember, in order for us to factor this, we will use the x. We multiply a times c for the top. Our b value goes at the bottom. We'll then split our middle term into the two factors we find and factor by grouping. And for this equation here, we will get y equals x plus 1 times x minus 3. So if I take this information to the left and put it on our graph, again, we have our vertex at 1, negative 4. 1, negative 4. And our a value is 1, and it opens up. So our graphing pattern is the 1 over 1, 4 over 2, and 9 over 3. So I go up 1 over 1, and that is my y-intercept that we already identified as well at negative 3. Up 4 over 2, and up 9 over 3. So this is the graph for y equals x squared minus 2x minus 3. So a couple of things I want to point out, and I know that we've talked about this before, is the relationship between factored form and our graph. So what you'll notice is that in our factored form, we have x plus 1 and x minus 3. And we've talked about how the numbers, which are the x-intercepts, are related to that factored form because they're the opposite values. So we have x-intercepts here and here at negative 1, 0 and positive 3, 0. And so there is a relationship here between the factored form and the x-intercepts where the x-intercepts are the opposite value of the factors that we see. The other thing I want to keep in mind is that when we're looking at the x-intercepts, we are on the y-axis, which means the value of y is 0. So if you look at both of our x-intercepts, you'll see that the value of y is 0. And so what we're finding here is the solutions of this quadratic when y is 0. Now so if we had this equation here, we could say 0 equals x plus 1 and x minus 3. And that's when y is 0. But it's not strictly used when y is 0. So what we could do is we could take a look at these points here. At this point here, at both of these points here, our y value is a positive 5. So what we would be able to do is say, okay, well, what would our solutions be when y equals 5? And we could use solving, in this case by factoring, we could find our x values at those points. But we can see here on the graph that our x values are negative 2 and positive 4. So when y equals 5, I substituted that 5 in for the y, our x values would be negative 2 and positive 4 based on the graph. But again, we could use an algebraic method, we could use factoring here to find those solutions. And that's what we're going to look at in our lesson today. So just some vocab for you guys. Our first term is standard form of a quadratic, which we just talked about on the last slide, y equals ax squared plus bx plus c. X-intercepts, remember those are where the graph intersects the x-axis, and this is where y is equal to 0. Our x-intercepts are also going to be referred to as zeros, solutions, and roots. We refer to them as zeros because this is where y equals 0. We refer to them as solutions because we're solving the equation for x. You know that they are x-intercepts, and then we're going to get to roots in our next lesson. But I want you guys to be aware that all 4 of these words are referring to solving for the x values. We have the zero product property. The zero product property states that if A times B is equal to 0, then A must equal 0, or B must equal 0, or both. So if you think about it, if you multiply 2 numbers together to equal 0, one of those numbers has to be 0 in order for you to get 0 when you multiply. Well, I want to take a look at this in terms of what we're going to see today. So for example, if we say that x plus 3 times x minus 7 is equal to 0, we're multiplying x plus 3 times x minus 7, then x plus 3 has to equal 0, or x minus 7 has to equal 0. And in this case, if we solve for x, this means that x has to equal -3, or x has to equal +7. We subtract to the 3, we add the 7, and that solves for those x values for us that will make this equation here equal to 0. So we're going to factor and apply the zero product property to our problems today. One more thing before we get to our guided practice problems. I want to take a look at 3 different situations, and what you'll see here is that in this case here, this graph has 2 x-intercepts, and in this case, that equation would have 2 real solutions. Okay, so we've talked about the numbers that are not real numbers. In this case, these would be our real solutions. Right here, this is 1 x-intercept. This equation would have 1 real solution. And for today, notice that this graph here does not intersect the x-axis, which means that this equation would have no real solutions. So when we're solving, we're looking to determine what those solutions are. And this is what we are looking for, those x-intercepts. So again, the first case shows that we have 2 x-intercepts, 2 real solutions. The middle case is 1 x-intercept, 1 real solution. And in this case here, which we won't see today, but we will get to these later in the unit, this equation would have no real solutions. So let's go ahead and take a look at some guided practice problems. So I went ahead and included some toolbox items with our guided practice problems today. They're going to be the same for each of them. But the first thing that we always have to check for is to make sure that our equation is equal to 0. So right now, this equation is already equal to 0, so that is already taken care of for us. We don't have to worry about that step. From there, we need to check to see if we can factor out a GCF. So our coefficients here are 3, 20, and 7. They have no common factors, so we don't have to worry about that for this problem. From there, we're going to go ahead and we're going to factor using the x. So for the x, I multiply a times c. That's going to give us -21. Our b value is negative 20. That's going to go at the bottom of the x. So we're looking for factors of 21 that are going to add up to negative 20. Our factors are going to be 21 and 1. Because we're multiplying to get a negative, 1 must be positive, 1 must be negative. Because we're adding to get the negative, the bigger number must be negative. So from there, we can go ahead and split our middle term. So we have here 3x squared minus 21x plus 1x minus 7. And this whole thing is still equal to 0. From there, we want to go ahead and group our terms. Take out the GCF of the first group, 3x and 21x are both divisible by 3x. When we divide that out, that leaves us with x minus 7. For the second group, we have x minus 7. X and 7 have no common factors, so we're going to take out that positive 1, and we're still left with x minus 7. And again, remember at this point, you have to make sure that your parentheses match. Otherwise, it hasn't been factored correctly. And then from there, we can put this back together in factored form as 3x plus 1 times x minus 7. So this is our factored form. So in your practice today, you're going to see the questions broken down into two parts. Part A asks for you to write your equation in factored form, and that's going to look like this. The second part asks for you to solve. So what we have to do from here is use the zero product property to find our values of x. So remember, if these two multiplied together equals 0, then one or both of our factors have to equal 0. So from here, we're going to use the zero product property. We're going to set each of our factors equal to 0 and solve for x. So for 3x plus 1, we have to subtract the 1 on both sides. That's going to give us 3x equals negative 1. Then we will divide both sides by 3, and we will get x is equal to negative 1/3. For the second one here, x minus 7 equals 0. We add the 7 to both sides, and we get x equals positive 7. The last thing I want to talk about before we move on to the next guided practice problem is what this means. So we just saw in the previous slide that the solutions are the x-intercepts. So in this case, going back to the explore problem, we're saying that y equals 0, which means that where x equals negative 1/3, y equals 0. Where x equals 7, y equals 0, which means we just found the x-intercepts. So if we were to look at this on a graph, we would have x-intercepts at negative 1/3 and positive 7. So we have a parabola that intersects the x-axis at both of those values. This is just a sketch. This is definitely not to scale. This x-intercept is negative 1/3. This is where x equals negative 1/3. And this is where x equals 7 on the graph. And again, both of those are where y equals 0. So just to finish up our toolbox, we factored using the x. Once we have factored form, we have to set each factor equal to 0. And from there, we will solve for x. All right, so let's take a look at a couple of more guided practice problems. Oops. Okay. All right, so here we are. We have negative 3x squared minus 12x minus 12 is equal to 0. So again, we're looking for where y equals 0. We're looking for those x-intercepts. First thing we need to do is make sure the equation equals 0, which we have. Check for a GCF. So here we have negative 3, negative 12, and negative 12. Now remember, when we're factoring, if a is ever a negative, we have to factor that negative out, regardless of the other terms. So here we definitely have to factor out a negative, and 3, 12, and 12 are all divisible by 3. So we're going to go ahead and factor out the negative 3. as the GCF. When we do that, that leaves us with x squared plus 4x plus 4 From there, we're going to factor using the x, so we multiply a times c. So we're just factoring what's in the parentheses now. Our a value is 1, our c value is 4. That's going to give us 4, and our b value is also 4. So factors of 4 that add up to 4 are going to be 2 and 2. We're multiplying to get a positive and adding to get a positive, so these will both be positive 2's. From here, we're going to go ahead and split that middle term. So we have x squared plus 2x plus 2x plus 4. Remember, the first term stays the same, the last term stays the same, but the middle term gets broken up. We will group those into two groups. GCF of the first group is x. That leaves us with x plus 2. GCF of the second group is 2. We're going to take out that positive as well. That leaves us with x plus 2. Check your parentheses. Put our factors back together. We have x plus 2 times x plus 2. And our GCF was -3, so we have to put that out in front. So this here, again, is our factored form. When we're asked to identify factored form, this is how our equation should look. So once we have factored form, our next step is to set each factor equal to 0 so that we can then solve for x. So at this point, we don't have to worry about the -3. The -3 is not going to give us an x value. So if you remember, we're looking for those x-intercepts, and the x-intercepts are going to come from those x values. So the -3, the GCF, when it's a number, is not going to have any bearing on what our x-intercepts are. Remember, the job of the a value is to shrink or stretch our graph and to tell us if there's a max or min. So it's going to tell us whether the graph opens up or down. So what we want to do from here is take those factors with the x's, the x plus 2's, and we're going to set them equal to 0. So we have x plus 2 equals 0 and x plus 2 equals 0. We solve for x, we subtract 2 on both sides, we get x equals -2. We subtract 2 on both sides, and we get x equals -2. Well, these are the same number, right? So what we got here is that we have an x-intercept, and it's an x-intercept because y equals 0, of -2. Well, let's look at that graphically. What does that mean? If we only have one x-intercept at -2, graph opens down, that means that that x-intercept is our vertex, which means that there is only one real solution for this equation. So again, when you get the x values that are repeated, that are the same, it's because there is only one solution, and that is when the vertex is the x-intercept. All right, let's take a look at a couple more. All right, so here we have 2x squared minus 12x equals 0. Make sure that our equation is equal to 0, and it is. So in this case, again, we're solving for the values of x when y equals 0, so we're looking for those x-intercepts. From there, we're going to check for a GCF. So from here, 2x squared minus 12x, they're both divisible by 2, and they're both divisible by x. So I'm going to factor out 2x here, and that leaves me with x minus 6. Now at this point, I no longer have I have a quadratic, but it's no longer in standard form, which means that we do not have to worry about factoring using the x for this question here, because when we factored out the GCF, it left us with our two factors. This is our factored form. Now, a lot of students are forgetting that when you only have two terms, well, when you have your A term and your B term, that you just factor out the GCF, and that is your factored form. This was on the common assessment, and a lot of students forgot this. So make sure that, again, we are always checking for that GCF first, and if there's nothing else we can do from there, then we are in factored form. So from here, we're going to take our factors and we're going to set them equal to 0. Now, I know I told you on the previous slide that the GCF, when it's numbered, doesn't affect our answer, and I want to show you that here. So what we have here is a factor of 2x and a factor of x minus 6. So from here, we have to set each factor equal to 0. So if I set 2x equal to 0 and x minus 6 equal to 0, this here, I'm going to divide both sides by 2 to get x by itself, and that's going to give me x equals 0. Well, what we could have done here, because the GCF doesn't affect our root, is we could just take that x value and set it equal to 0, and that's going to give us the same x-intercept regardless. So either way, you can use the GCF and just divide it, or you can just use the x value because it's not attached to anything with addition or subtraction, and it's going to be equal to 0. Over here for the x minus 6, we have to add 6 on both sides, and we get an x-intercept of x equals 6. So we add the 6 to both sides, and we get an x value of 6. And that is our x-intercept, 6 when y equals 0. So if we were writing this as an x-intercept, we would write it as 6, 0. And if we were writing this one here as an x-intercept, that would be 0, 0. So again, graphically, what does this mean? We have an x-intercept at 0. We have an x-intercept at 6. Graph opens up, and we have two real solutions here. Okay, just one more. I want to make sure I cover everything. So lastly, we have 2x squared minus 3x minus 5 is equal to 9. So in this case, our equation is not equal to 0. So what we are now looking for is the value of x when y equals 9. Our first step, though, is to still make sure that our equation is equal to 0. So what we have to do here is subtract that 9 on both sides. So that gives us 2x squared minus 3x minus 14 is equal to 0. We want to check for a GCF. 2, 3, and 14 do not have any common factors, so there's nothing there. So here we will now factor using the x. 2 times negative 14 gives us negative 28, and our b value is negative 3. Factors of 28 that add up to 3, or in this case subtract to 3, are going to be 7 and 4. Multiplying to get a negative, one of our numbers must be negative. We're adding to get a negative, therefore our larger number must be negative. Go ahead and split our middle term. First term stays the same. Middle term becomes negative 7 and positive 4. And our last term stays the same. Group your terms into two groups. Take out the GCF from each group. 2x squared and 7x are both divisible by x. That leaves us with 2x minus 7. 4x minus 14 are both divisible by 2. I'm also going to take out the plus sign. And that leaves me with 2x minus 7. Our parentheses match, so we've factored correctly. We're going to put that back together, and our factors are x plus 2 and 2x minus 7. Again, this is our factored form. From here, we're going to take each factor and set them equal to 0. So x plus 2 is equal to 0, and 2x minus 7 is equal to 0. This gives us, subtract 2 on both sides, x equals negative 2. Add 7 on both sides, We get 2x is equal to positive 7. We then divide both sides by 2, and we get x is equal to 7 over 2. So one last time, let's take a look at what this means. So remember what we solved for here is when y is equal to 9, and we got x values of negative 2 and 7 over 2. So if we take a look at this, when y equals 9, which is up here, y equals 9, x will equal negative 2, and x will equal 7 over 2, and this is 3.5. So we're going to have a parabola, something like this. And again, because it was equal to 9, the x values are negative 2 and 7 over 2 when y is equal to 9. This is solving with factoring. Make sure you answer your essential question.